All right, my mathematicians, we are back with section 8 of chapter 2, literal equations and dimensional analysis. So previously we solved equations with variables on both sides, and now we're going to solve equations for given variables. And you'll see we're going to have equations that have more than one variable, and we're going to try to solve for one of those variables. And then in the second video, we're going to use formulas to solve real world problems so we can actually see how this shows up in an actual context. So vocabulary, literal equation, dimensional analysis, and unit analysis. So in this video, we want to talk about how to solve for a specific variable. And then in the next video, we'll get into actual real world problems. So some equations, such as the one above, contain more than one variable. At times, you will need to solve these equations for one of the variables. And it's said above, but down here, it's actually below. All right, so we want to solve 4m minus 3n equals 8 for m. Okay, notice there's two variables, m and n. So you have to pay attention to which variable they are asking you to solve for, and you just follow the steps for solving an equation like you normally would, okay? Pretend like everything else is the same. So to get m by itself, we need to isolate m. We need to get rid of the 3n and the 4. So first thing we got to do is get rid of the 3n, so add 3n to both sides. Now you can't add the 8 and the 3n together to get 11 or 11n or anything like that, because the 8 and 3n are not like terms. They're not the same thing. 8 is a constant, 3n contains a variable, so you can't put them together. So now you have 4m plus 8, or 4m equals 8 plus 3n. Now to get rid of the 4, what do? Right, you divide. Now you got to divide everything on both sides by the 4. So 8 plus 3n, all of that divided by 4, not just the 8, okay? So then you can actually, since it's division by 4, you can break it apart into two separate fractions where you have 8 over 4 and 3 over 4n, and then the 8 over 4 reduces to a 2. So the fully simplified form is that m equals 2 plus 3/4 n. Okay, here's 4 for you to try. Go ahead and pause the video, give them a shot, and hit play when you're ready. Okay, we're back. So 1a, we want to solve this one for n. Okay, so let me just write it down. So we're going to subtract 6p from both sides. And since the 15 and the 6p are not like terms, can't put them together. Okay, then divide both sides by 3. Those cancel and you get n equals 15 over 3 minus 6 over 3p, which would be 5 minus 2p equals n. Okay, all right. B, I want to solve that one for k. So k minus 2 over 5 equals 11j. Now, to get the k by itself, I have to get rid of the division by 5 and then add the 2. So I'm going to multiply both sides by 5. So those cancel, and I have k minus 2 equals. Now, since this is 11 times j times 5, remember, if it's just multiplication, you can multiply in any order. So I could put the 5 and the 11 together and get 55 j, and then add 2. And you have k equals 55 j plus 2. Cool? All right, remember, you can't put the 55 and the 2 together because they're not like terms. The 55 has the variable j with it. All right, so 28 equals t times r plus 4. If I want to solve it for t, I know you were probably tempted to like distribute the t, but that's only going to complicate things because now you have two terms with a t in them. And what are you supposed to do with that? So since it's t times the quantity, we just need to get rid of that quantity and t would be by itself. Well, since it's multiplied by the r plus 4, that quantity in parentheses, I'm going to divide both sides by that. Okay, you're allowed to divide by a quantity, all right, because the t is multiplying. Since it's multiplication, the parentheses indicate multiplication, you can undo that by division. So it's 28 over r plus 4 equals t. Now that is the final answer. You cannot break it apart into 28 over r plus 28 over 4 and then get 28 over r plus 7. If you did that, you cannot do that because you are dividing by r plus 4. Okay, in the other problem, we had something, let's say it was 3 plus x over, let's say 8 plus 2x over 2. In that situation, you're only dividing by 2. So you can split it apart. It's like you're adding with a common denominator of 2. Okay, so you could split it apart into 2 fractions with a common denominator of 2. In this case, the denominator is r plus 4, and if you split it apart, you kind of like don't have a common denominator to be able to split it apart. Okay, so just know that if you're dividing by just a constant, yeah, you could split it apart into 2 fractions. Or if it's just one variable, you could split it apart into 2 fractions. But if you're dividing by a sum or a difference, you can't split it apart. So let's look at this one. A times q minus 8 equals 23. Now this one's a little bit different because here the q is kind of trapped inside of the parentheses, so we need to get it out of the parentheses. There's 2 ways we could go about doing this, and I'll show you both of them here. The first way is to divide by a, and you get q minus 8 equals 23 over a. Oops, not over 8, over a. And then add 8 to both sides. And you would get q equals 23 over a plus 8. Now it's not over a plus 8, it's 23 over a plus 8. Okay, the 8's not like snuck in the denominator or anything like that. The other way to do it is to distribute the a first. AQ minus 8a equals 23. Then add 8a. And you get AQ equals 23 plus 8a. Then divide both sides by a, like this. And then q equals 23 over a plus 8a over a. All right, since it's just over a, you can break it apart into 2 fractions with the common denominator of a. And then these a's would cancel, because it's a divided by a, and you would have 23 over a plus 8 again. All right, so either way, you're going to get the same answer. Okay? Cool beans. All right, so sometimes we need to solve equations for a variable that is on both sides of the equation. When this happens, you must get all the terms with the variable, with that variable. You know, you might have more than one variable, but if you're solving for one of the variables and they're on both sides, you need to get all the terms with that variable on one side and everything else on the other. Then it's helpful if we use the distributive property to get that variable by itself. And I'll show you what I'm talking about right here. So if I have 3x minus 2y equals xz plus 5, and I want to solve that for x, looks complicated. I know I got 3 variables, but you got x's on both sides. Okay, so what we're going to do is get the terms with x on one side and then everything else on the other. So first you want to get the 2y on the other side. So add 2y to both sides. And again, there's no other term with just y, so there's no like term, so you just have to write it as plus 2y. Okay? So you have 3x, well, you would have 3x equals xz plus 5 plus 2y. And then you want to get the xz to the other side, to the left side now, because it has an x with it, and you want all the x terms with an x on the left side in this case. Okay, so subtract xz from both sides. Now here you can't put the 3x and the xz together because even though they both contain an x, one has a 3 with it and the other has an x z, so it has another variable with it. So they're still not like terms. Remember, like terms have to have the same variables, and they also have to have the same exponents, but we'll talk about that when we get to that. So here, look, you have both terms with an x on one side and everything else on the other. Now here is the kind of trick that we can do to get x by itself. It's really like the problem had an x distributed to both of these terms. So if we use the distributive property in reverse and like undistribute the x from both terms, you could write it as x parentheses. Now you need the parentheses because remember before when we started with the distributive property, if you had like x parentheses 3 minus z like we do here, you would know you had to distribute it to both of them. Well, if you undistribute it, you still need the parentheses there to indicate that the x could be distributed to both terms. Otherwise, you would have x3 minus z, and nobody would know that the x was actually undistributed from both of those. Okay, so basically just use the distributive property in reverse to pull the x out, and now you have it as a product, x times the quantity. So like before, you just divide both sides by that quantity, and you get x equals 5 plus 2y over 3 minus z. Now again, same reasons as before with the common denominator thing, you can't separate that into like 5 over 3 minus 2y over z. You can't break it apart because you have a difference in the denominator. If it was just 3 in the denominator, you could break it apart. Or if it was just even a negative z in the denominator, you could break it apart. But here, since I have a difference, you can't break apart the denominator. Okay, so real quick, just how we did this. So we have terms that have the variable we want to solve for on both sides. So we get the terms with the variable that we want to solve for all on one side, everything else on the other. Then you use the distributive property in reverse to pull that variable out. So that's what we did right here. Then we just divided by the quantity that was multiplied by to get the variable by itself. Okay, and then one other like ninja tip here is that since you can't divide by 0 and these are variables, we just state that z can't equal 3, because if it was, if you plug 3 in here, it wouldn't matter what y was, but if you plugged 3 in, you'd have 3 minus 3, which is 0, and you can't do that. So that the reason we say that is because you have an equation here, and you're saying x equals something. Well, if you plugged in 3 for z, you're saying x equals undefined, which doesn't really make sense. Okay, so we just have to state that z can't be 3. All right, here's 2 for you to try. Go ahead and pause the video and hit play when you're ready. Okay, we're back. So the first one, d plus 5c equals 3d minus 1. We want to solve that for d. So I'm going to subtract 3d from both sides and get, now in this case, since this d is like a 1d and I'm subtracting 3d, you can actually combine those and get negative 2d because they are like terms. So that equals negative 1. Then subtract 5c. You have negative 2d equals negative 1 minus 5c. Divide both sides by negative 2. And you would have d equals negative 1. Oh, forgot the negative. Negative 1 over negative 2 minus 5 over negative 2c. Now, let me show you something. You can simplify this because negative 1 over negative 2, negative divided by negative is a positive, so it would be 1/2. And same thing with the minus 5 over negative 2. You're subtracting negative or negative divided by negative, still you can put it as 5/2 c. Now, I put the d's on the left and everything else on the right. If you put the d's on the right and everything else on the left, you should still get the same answer that I did if you did this correctly. Now, you may have not combined the d's, but in this case we could because the d's are actually like terms. Okay, so I'd have to see your work if you didn't do that, so feel free to reach out to me if you didn't combine the d's, and then I could walk you through what to do, and if you did make a mistake or you just forgot to combine them. Okay, so for the second one, we want to solve this for q. So you got 6q minus 18 equals qr plus t. Again, you want to get the q's on the one side and everything else on the left, or everything else on the other side. So I'm going to put the q's on the left by subtracting qr from both sides. Now here, I cannot put the 6q and the qr together because they are not like terms, because the 6q only has a q and the qr has a variable of r. Remember, you need to have the same variables. All right, so then we add 18 to both sides, and you have 6q minus qr equals t plus 18. Now, since both terms have a q, what can I use? Right, the distributive property in reverse. So q times 6 minus r equals t plus 18. Then divide both sides by 6 minus r. And those cancel. And I'm going to put my answer up here. Q equals t plus 18 over 6 minus r. Cool beans? And again, if you put the q's on the right side and everything else on the left, your answer might look different, okay? Because you put everything on the other side. Hopefully you didn't, but if you did and you're not sure if you got it right, feel free again to reach out to me. All right. All right, guys, that's it for this one. In the next video, we're going to talk about how to apply this into a context. So we will see you there.